Today question, it's from heat and electric field as well, from both types. It's not the same question, but it's two different questions. But the question model is, check whether you have seen these type of questions. It's an exchange actually between two sides, and we need to figure out which part gives the others or anything like that, and we need to figure out what is the common factor between two sides. So that is the tricky thing here. So these type of questions are not are challenging for sure, but it's common, right? So try to find whether there are these type of questions in other subject areas as well. So let's do these few questions. And so I'm here suggesting you to find these type of questions and do it, because it's a bit challenging, and it's always better to be familiar with these type of questions, right? So let's do these questions, right? So do one question, stop there, and yes, go through the explanation, then go to the other question. That's the normal procedure. Let's do it. Right, this is the very first question. Try the question, try to get the answer, and if you can do the question, that is great. So try your best. All right, I hope you have tried the question now. If you could get the answer, that is great. Right, let's get into the question now. Two identical bulbs are connected using narrow tube, both containing same amount of gas with mass m, right? So m and m, initial temperature of both T. Now one of them is heated to T1. Find the mass of the gas delta M transmitted from one into another, right? So we need to figure out why. So let's say this is T1, so it's heated to T1. So what happens is, actually the pressure is the common factor here. Until the pressure equals in both bulbs, the amount of molecules, so mass actually will move into one to the other, right? Let's say now, let's apply PV equals nRT here. PV equals nRT. So what happens if the temperature is increased to T1? See, so in this part, if the volume is constant, you can see the volume is constant, so pressure will automatically increase, right? So what actually happens to maintain the same pressure just outside here? So pressure here will be, again PV equals nRT, let's apply. So temperature, the previous temperature. So here the pressure will not change, right? So to increase the pressure, so here the pressure is increasing now. This part, let's say this is B and this is A. So pressure at B is increasing. So somehow we need to increase the pressure at A. So the only method that is available is to give some mass into this delta M. So what happens is, when N number of molecules increases, again pressure will increase. So that is the purpose, right? So let's assume now the amount of mass goes is delta M. So let's apply the equations again. Pressure has to be same, right? So PV equals nRT is our equation now. So let's go with it. So the increased pressure here, P1 will be equals nRT1 over V. So let's assume total mass N, actually N is mass divided by molar mass. So here I can write, so certain amount of mass goes out. That means we have here only now simple M divided by capital M minus, yes, delta M divided by capital M. So this is the N remaining here, R and T, T dash and V is there as well, right? So on the other hand, from the other side, actually let's write the equation for this side. So what happens is, mass will increase, N will increase, right? So initially we had M, capital M, plus now we have delta M over capital M. So this is the amount remaining here now, the transit amount, right? So this into R into T and divide by V, that is pressure. So both pressures has to be equal. So what we have to do is, we have to equalize them now. Now what we have to do is, we have to equalize these two, right? So M divided by capital M plus delta M divided by capital M into RT over V equals same thing. Let's write M minus delta M over capital M RT V, right? So let's cancel off the values that are right easy to remove, right? So RT and V actually R and V same, you can see that T1 it's pressure temperature is here T1, so here it's T, and again you can see this capital M also common, so I can remove this capital M as well. That goes right. Let's write the equation now. Okay, so it's now M plus delta M into T equals, it's simple M minus delta M into T1. So what we have to do is we have to subject delta M now, right? So let's remove the bracket. MT plus delta MT equals MT1 minus delta MT1. So we can bring it here and we can bring it there, right? Right. So now we get delta MT plus delta M T1, and on the other side we have MT1 minus MT, right? So we need to subject delta M here. So delta M equals to M bracket T1 minus T divided by T plus T1. I hope you can see it. So MT1 minus T and T plus T1. Let's see what is the answer. Yes, it's the second answer. I hope you can see it. It's the second answer, right? So this kind of a question actually we need, it might take time just to clarify, but still if you know the theory you can easily do the question. Alright, you have tried the other question. Now you know the similarities between these two questions. So I hope you can see the common factor. Let's do the question now. Alright, moving into the second part of the question. So just like the very same question we did earlier, it was actually a heat question. This question is from electric field, see, but still the same connection here. So let's read the question first. I hope you can, if you haven't done this question, yes, you can try this question now. Find the connection between these two, and if you can do the question, that's great. Try the question and then come back and let's see the explanation. Okay. Two metal sphere of radius 2r and r are given equal charges. You can see equal charges are given. Later they were connected using a metal wire. Find the exchange charge Q from one to the other, right? So initially Q is given to both, right? So then these two are connected, right? Once these two are connected, remember, just like it happened from the other question, the pressure has to be equal. So here the potential is the key here. Potential, until the potential is equal, the charge will be exchanged. So in the other question, until the pressure was equal, mass was exchanged, right? So here the same. So let's assume simple Q, charge will move from one to the other, right? Let's say let's see, right, let's write the potential first. So potential here, it has to be, I hope you remember the equations, 1 over 4 pi epsilon Q over R, and here it's again same 1 over 4 pi epsilon naught Q over 2R. So you can easily see the potential is higher in the smaller one. So what happens is actually a charge of simple Q will move here. So total charge of here now Q plus Q, and here we have Q minus Q. So what we have to do is we have to equalize the potentials. So let's equalize the potentials. Let's write the equations we know now. Right, now the potentials are equal, right? Let's simplify the value. 1 over 4 pi epsilon 1 over 4 pi epsilon cancel off, and here R and R cancel off. So we get Q plus simple Q over 2 equals Q minus Q, right? So 2 goes up here. So Q plus simple q equals 2q minus 2q. So let's put this value here and other than there. So it's q equals simple 3q. So simple q equals q by 3. So the exchange charge from small sphere to large sphere is q by 3. So the answer we are looking for is the third answer, 3. Right. So remember, when in this type of questions, actually we need to figure out what is the factor that has to be common, that has to be equal. Right. So this is a question type. So find out similar type of questions and practice. Actually, even in other subject areas also, there can be questions like this. So if you have any idea, yes, you can comment down there. We can discuss these questions as well. Right.